The conclusion of Rolle's theorem also holds when the condition fa is equal fb is 0 is replaced with fa is equal fb. So if your function f continuous, it is differentiable. In Rolle's theorem we said if fa is equal to fb is equal to 0, then so we conclude that there exists c such that f prime c is equal to 0. Here it says that if fa is equal fb and not possibly equal to 0, maybe it will be equal to 1 or 2 or 3 or any other number, then also the conclusion will hold. That means also there will be c such that f prime c is equal to 0. So here we have this graph where this function f is continuous on the closed interval a to b, differentiable on the interval a to b. Then here we have fa is equal to fb, where fa is not equal to 0 and fb is not equal to 0 also, but they are equal. So there exists c such that f prime c is equal to 0, or we have a horizontal tangent line in the interval a to b. So بالمختصر يعني لو كانت الفانكشن continuous، لو كانت differentiable، بالإضافة إلى أنه ال fa تساوي fb، لكن ما له شرط أنهم يساوي صفر، ممكن يساوي any other number 1 2 or any other number. إذن بعدنا نقدر نقول إنه there is c such that إنه f prime c is equal 0. Now the main value theorem, let f be a function that is continuous on the closed interval a to b and differentiable on a to b. Then there exists a number c in the open interval a to b such that f prime c is equal fb minus fa divided by b minus a. So if your function f is continuous, also it is differentiable, then there is c such that the derivative of f at c is equal fb minus fa over b minus c. If you look to this term, it will be the slope of the secant line. This one will be the slope of the tangent line at the point C. So the main value theorem, f should be continuous on the closed interval, differentiable on the open interval a to b. Then there is c in the interval a to b such that إنه f prime c is equal fb minus fa over b minus a. معناته إنه السلوب للتانجنت لاين عند البوينت c يساوي سلوب للسيكنت لاين. فعندنا مثلا الفانكشن هذه continuous graph of a function f which is continuous on the closed interval a to b. طبعا نفس الحالة it is differentiable on the open interval a to b. We conclude that the derivative of this point or the derivative of the graph at this point will be equal the slope of this line. This line is from a to b is the secant line. And here if we draw another line at this point, for example at the point D, we will have this one, it will represent the slope of the tangent line. If you see here, the tangent line will be parallel to the line, this one, which is the line passing through the point A, B. So the slope of the tangent line at this point will be the same as the slope of the secant line. يعني لو كانت الفانكشن continuous كانت الفانكشن differentiable، إذا السلوب للتانجنت لاين عند نقطة محددة اللي هي C بيكون يساوي السلوب اللي هي secant line اللي هو القاطع، بما أنهم parallel. Two lines are parallel so that means they have the same slope. أساس كده إن إحنا قلنا إنه هنا السلوب للتانجنت لاين هو نفسه السلوب للسيكنت line. So tangent line are parallel to the secant line through the point A, FA and B, FB. Sometimes we have just one point C in the interval A to B where the tangent line and the secant line are parallel, and sometimes we have more than one C. For this example we have two C, this one at this point F prime C1 and here we have F prime C2. Both of these tangent line are parallel to the secant line through the point A to B. يعني أحيانا يكون عندنا واحد tangent line يكون parallel للسيكنت، أحيانا يكون عندنا أكثر من line. هنا في الجراف الأول هنا عندنا بس عند النقطة C، لكن في الجراف الثاني عندنا عند النقطة اللي هي C1 نفس الشيء عندنا عند النقطة C2. يعني نفس الحالة في نفس لما قلنا في الرولز ثيرم أحيانا تكون عندنا C واحدة، أحيانا تكون عندنا أكثر من C. نفس الطريقة في المين فاليو ثيرم أحيانا تكون عندنا C واحدة اللي هي الديريفيتيف للفانكشن عند النقطة C تساوي الديريفيتيف للسيكنت لاين، وأحيانا تكون عندنا أكثر من نقطة، يعتمد على الفانكشن. Now let us do this example. Let fx is equal x square minus 2x square, x power 4 minus 2x square, where x on the interval minus 3 to 3. Verify the hypothesis of the main value theorem. B. Find values of C such that satisfy the conclusion of the main value theorem. The hypothesis of the main value theorem, f should be continuous, f should be differentiable. If f is continuous differentiable, then we conclude this conclusion that f prime c is equal to the slope of the secant line. So we need to show this function is continuous and differentiable. Since this function is a polynomial, so it should be continuous on this interval minus 3 to 3, and also f it should be differentiable on the open interval minus 3 to 3. So we said it is continuous differentiable because it is polynomial. So f is continuous differentiable, that means it satisfies the hypothesis of the main value theorem. Part B, we need to find values of C such that satisfy the conclusion of the main value theorem. We said if our function continuous differentiable, then there is C such that f prime c is equal fb minus fa over b minus a. So now we need to find f prime c is equal fb minus fa over b minus a and solve for c. So f prime c, first we need to find the derivative. It will be 4x cubed minus 4x. So we need it as a function of c. So it will be 4c cubed minus 4c is equal fb minus fa. We have the interval minus 3 to 3. So this is a, this b. So f3 minus f minus 3 divided by 3 minus 3. So this will give us 4c cubed minus 4c is equal f3 minus f minus 3. f3 here will be 3 power 4 minus 2x multiplied by 9. f minus 3 will have the same answer since this one is even, this one is even. So f3 will be equal to f minus 3, so that's why here we will get 0 divided by minus 6, which is 0. So the derivative f prime c is equal to 0. Now we want to solve this one for c. If you take 4c as a common factor, you left with c squared minus 1. So 4c is equal to 0, or c squared minus 1 is equal 0. From here, 4c is equal to 0, that means c is equal 0. From c squared is equal 1, so c is equal plus or minus 1. If you see all this 3, so 0, 1, minus 1 will be in this interval here minus 1 to 1. So this function satisfies the hypothesis of the main value theorem. Then we have example 4, fx is equal root 4x plus 1 on the closed interval 2 to 6. Verify the hypothesis of the main value theorem. Then we need to find C that satisfy the conclusion of the main value theorem. If we see the domain of this function, it will be 4x plus 1 will be greater than or equal to 0. That means x greater than or equal minus 1 over 4. So the domain from minus 1 over 4 to infinity. So we are given the interval 2 to 6, which is apart from this interval. So our function is continuous on minus 1 over 4 to infinity. So it will be continuous also on 2 to 6. Also it will be differentiable on the interval 2 to 6 because we can find the derivative for any number in this interval 2 to 6. So we conclude that f satisfies the hypothesis of the main value theorem. Then we need to find part B. Find the values of C such that satisfy the conclusion of the main value theorem. So we need to show that, or we need to find C such that f prime c is equal fb minus fa divided by b minus a. So now first we need to find the derivative of this one will be 1 over 2 multiplied by 4x plus 1 power minus half multiplied by the derivative of 4x plus 1, which is 4. So if you replace this, if you replace x in the derivative by c, you will get f prime c is equal 4 over 2 multiplied by 4c plus 1 all power minus half is equal fb, which is f6, minus fa, f2, divided by b minus a, it will be 6 minus 2. So now if you simplify this, f6 is equal square root of 4 multiplied by 6 plus 1. this will give us 5 minus f2 will be 4 multiplied by 2 plus 1, 9, so square root of 9 will be 3. So 5 minus 3 divided by 6 minus 2, which is 4. So 5 minus 3 will be 2 divided by 4, this will give us half. So now if you simplify this one, so this will be 2 multiplied by 4c plus 1 power minus half is equal half. So it will be 1 over root 4c plus 1 is equal 1 over 4. If you do cross product, it will be square root of 4c plus 1 is equal 4. If you solve for c, so c will be equal 15 over 4. 15 over 4 will be in this interval 2 to 6. So this is the c of our function f. Then we have a theorem for 3, which is talk about the constant function. It said if f prime x is equal to 0 for all x in a to b, then fx is equal to c, where c is a constant. يعني إذا كانت المشتقة تساوي صفر لأي number موجود في الانترفال a to b، إذن على طول we can conclude that fx is equal c. يعني معناتها إنه الفانكشن الأصلية عبارة عن constant. So let us prove this one. Let us take 2 points x1 and x2 where x1 و x2 موجودة في الانترفال a to b. إذا كانت x1 less than x2، إذا نحن عندنا x1 و x2 موجودة في الانترفال a to b، بحيث إنه x1 أقل من x2. By let us apply mean value theorem, there is a number c in the interval x1 x2 such that fx2 minus fx1 divided by x2 minus x1 is equal f prime c. إذا المين value theorem تقول إنه f prime c تساوي fb minus fa over b minus a. إحنا عندنا ال a وال b عبارة عن x1 و x2، بحيث إن ال x1 عبارة عن a، ال b عبارة عن x2. فلما نجي نطبق عبارة عن fx2 minus fx1 divided by x2 minus x1. بس هنا قال إنه ال f prime x تساوي 0 for any value x. إذا ال c موجودة هي في الانترفال a to b، بما أنه قلنا إنه عبارة عن equal to 0 for any x موجودة في الانترفال، إذا f prime c should be equal to 0. فلو سوينا fx2 minus fx1 over x2 minus x1 is equal to 0، بيصير لنا ناخذ البسط ونساويه بالزيرو. يصير عندنا fx2 minus fx1 تساوي 0. إذا لما أنقل fx1 للطرف الثاني بيصير عندي fx1 تساوي fx2. طبعا متى fx1 تساوي fx2؟ طبعا نحن أخذنا x1 والx2 any arbitrary number، يعني أرقام عشوائية ما محددة. فلما يطلع لنا fx1 تساوي fx2 معناته أنا إذا أخذ أي قيمة x1 و x2 موجودة في الانترفال a to b أحصلهم متساويات. إذا معناته متى لما أخذ أنا أي قيمة بعوض فيها في الفانكشن يطلع لي نفس القيمة، شرط واحد إنه هو تكون الفانكشن مالها constant. إذا بما إنه يطلع عندي ال fx1 تساوي ال fx2، معناته أنا لما أخذ أي نمبر x موجودة في الانترفال a to b دائما أحصل على نفس الناتج. طبعا هذا ما يصير لأي فانكشن، لازم تكون الفانكشن مالها constant. على أساس كذا إنه لو كانت الديريفيتيف is equal to 0 for all number x in the interval, then fx is equal to c is a constant.